All right, hi everyone. Good morning if you're in Perth or WA. Just past midday in the eastern half of Australia. And I'm Simon Yin from the University of New South Wales. I'm a research software engineer, where I've been together with a team of 5 of us, helping researchers with performing programming tasks on some of the platforms that we support at our Research Technology Services group. So today I'm just going to run through, this is going to be a relatively short lunch and learn session. There's going to be a quick review and some background material about cloud computing for researchers. And then we're going to have a quick review as well of my article that I've written. I hope some of you have taken some time to read it. Then we're going to have some time for questions. Hopefully most of those would be related to what you need to do to join the Pawsey Nimbus cloud, if you're interested in joining or getting some allocations. And then finally, there's going to be sort of a quick live demo showing how to run an R-Shiny web app. So this R-Shiny web app is a good one to show some of the features, some of the convenience that this cloud platform brings. And it's also a very current topic. It shows some of the COVID-19 data sets that have been collected and visualized. Okay, so let's quickly talk about cloud computing. We can't talk about cloud computing, I guess, without talking a bit about the systems or the platforms that have existed before the Pawsey Nimbus cloud. And I guess some of you may know some of these, have even used some of these yourselves. But the cloud actually, I mean, you can't talk about the cloud without talking about some of the commercial players. And the ones that we deal with, many of us deal with, is the AWS, Amazon Web Services. There's also the Microsoft Azure cloud. Some of you may also know of the Google Cloud Platform. And if you've been a researcher around since, I think it's about 2014, then you've probably met or heard of the Nectar Cloud. So what's happened is that research projects nowadays are increasingly not just consumers of software. So if you're running a research project, quite likely in the past you may have used some commercial software packages and you delivered some results. But increasingly, research projects are now not just the consumers of software. The research projects have also largely become integrators. Research projects have become integrators of open components. And the resulting deliverable outcome from such projects are sometimes referred to as pipelines, or sometimes also referred to as workflows. And research projects now increasingly release software. So projects are not just consumers. Projects are now participants in a software release cycle. And you can see this as a growing trend if you look at the code hosting site GitHub, where you can find increasingly pipelines, research software alongside the more general IT industry projects. So what's happened is that there's now become increasingly a wide availability of software innovations. And the innovations I'm referring to here are cloud computing, or the cloud, and containers. So these are 2 innovations relatively recently, that have made what we sometimes call system operations, or systems generally, to be integrated as another software component. So not only does research software specific to a research domain now get released. But so does specific systems requirements, which are now simple, or at least easier, to automate as part of a software development process. This brings the potential to increase interoperability and reusability. And here I believe the ultimate goal is to have, ultimately, if everything works as it should, a self-service, something close to a self-service, something with simple instructions, and where a researcher can walk up to it, perform tasks that are unique to that researcher's area of interest. Sometimes they have requirements that somehow don't quite fit in with a large IT organization's setup, and a researcher needs to do some of this themselves. A good cloud platform should be able to accommodate such a person without too much difficulty, without having to learn too many things, and cut straight to what they're trying to do relatively quickly. So we've had in at least 5 years now, some of the commercial grade cloud. So we've got the AWS cloud, the Azure, the Google Cloud Platform. These are the commercial grade. I guess they're the front runners. And UNSW, I can say, has supported research projects to use these clouds, the AWS, the Azure, and Google clouds, for a few years now. And based on 2 projects here that I've been involved in the last year, using these commercial grade cloud platforms, it requires an upfront focus on cost control and on continuous usage monitoring. So we at Research Technology Services have helped research groups to understand the costs of running on these commercial grade clouds at a proof of concept level, right? So I've seen a few of the other commercial alternatives, and I've also in the past looked at Nectar. So Nectar has been a publicly funded cloud project, cloud platform, and it's been the cloud platform that research collaboration has been targeted on. But it's been successful largely, I believe, in Victoria, to some degree in Queensland. But in New South Wales, we've not achieved the uptake of Nectar quite to the same degree as been seen in those other states. And I was involved at some point early in Nectar, gave it a go as an early adopter. And during the early days, I found the user experience a little bit unstable. I found the support of Nectar, or the support available when trying to use Nectar, was not competitive really with the likes of AWS. So that's the background that I guess leads to this article, which I hope you can all see. So it led me to find out, when I found out that the Pawsey Supercomputing Center had decided to launch a cloud of its own, maybe moved away from the Nectar cloud, I was interested because I was thinking, well, perhaps here's something that will build on Nectar and then offer some of the things that we like in the commercial cloud platforms. So naturally enough, I think Pawsey's made a good decision to keep the name Nimbus. And the way I found out through Nimbus about Nimbus was, I'll just share it here quickly, was through a media announcement. So I thought this was a good way to release to bring out the news, and I thought it was a good way as well to introduce people to the capabilities of this cloud. and it looked quite substantial. I mean, if you look here at some of the numbers that I talked about, this is a substantial platform. So I was then interested to say, well, what if I'm a researcher? I sort of have tried some of the other cloud platforms. I know a little bit about them. How easy is it for me to get involved, to try this? Can I get an allocation? So I started the process of signing up. Now, with any publicly funded resource, the communication of its availability is important, I believe, because there is often, and I think I had some of this in the Nectar days when I tried using Nectar earlier, is that as a publicly funded resource, there's often confusion about eligibility and costs. So I was on the lookout for clear communication from Pawsey that that I qualified to use this. So I kept an eye out for that. And I was also going into this with sort of some expectations to see whether any of the shortcomings from previous platforms, such as Nectar, have been overcome. So my expectation then, going into reviewing this with sort of a fresh look at it, was that I was expecting it would be somewhat competitive with AWS and Azure, at least at a basic level, for use with research projects. And if you want to know the end of this, and if you haven't read the article, I can tell you that it is indeed the case. The Nimbus Cloud does live up to some of the promise of having an easy platform, publicly funded, with quite good responsiveness, service responsiveness. So I've written this article a little bit like an opinion piece, I guess. I've asked the question, I've looked at the material released, and I thought, well, if I'm a UNSW researcher, how do I know that I qualify? How do I know that I can use this resource that's in WA? So I gave this full marks, really, because I thought it's very clear, it was well conveyed from the website. And I'll show quickly the picture. Okay, it's got some photos, some stock photos, but it does say clearly, it's worded pretty clearly, and I like the fact that it did this, that Pawsey did this, that Nimbus is clearly stated is national research specific cloud service, open to any Australian researcher, including state government. So I took this as a firm yes, right? And I like the fact as well that having confirmed that it was something I could qualify for, I could apply for, right? So the promotional stuff is done quite well here, I feel. The next thing then is I was interested in seeing how quickly you could sign up. So not just what you had to do in terms of interacting with the Pawsey website, the sign-up process, but how long the turnaround time would be from trying to apply and actually being able to log in and to actually do something. So here, if you've used the commercial cloud platforms, you're paying with your credit card, so things happen quite quickly. And I guess it's maybe not reasonable to expect the same type of turnaround with the Pawsey Cloud. But the thing was that I found at this point that the experience of Nectar, I could see some similarities to if you've used Nectar at this point. So I gave this a 2 out of 4. So some parts of this I thought were good, in the sense that a little bit of the Nectar, the good part of Nectar, was present in the Pawsey Nimbus Cloud. And the reason I say that is if you look at what it does when you first start signing up, you start off with something which you may or may not have seen before, but it's called Australian Access Federation. So this is a federated login or identity service. And if you, I mean, I've met this several times myself, but if you haven't, it's quite straightforward, where it leads you through one step to the next. You find your university or your provider, what's called ID provider. So I'm from UNSW, so all I had to do was to enter UNSW. UNSW came up as an option. So all this I could do with no intervention. I could just drive it self-driven. I felt that I was getting through this very quickly. The next step was to ask me for my UNSW logins, which not a problem. And then I straight landed in a application portal, which looks pretty well designed, and I quickly found my way through this. And I was looking for how to make an application, and I saw the links, and then some very informative pages here to get you through. And I quickly saw, okay, I'm looking for Nimbus, so I found that, and I thought, well, I'm going to be a new user. So this was good flow. I thought this was good design. They're well put together. And then I reached the first step where I had to sort of think about what I was doing. So the sign-up process was actually, at this point, pretty fast. I had everything I needed. And then at this point, I guess if you're a researcher and you're familiar with applying for your grants, this is also not such a difficult. I hope you can see the fine print here. But it's basically a page that asks you for your field of research. You need to know some codes. You need to know some grant number. So you're going to provide some credentials to this portal. Now, at this point, when I used Nectar in the past, this is where the process tended to have a problem. So I was looking for an improvement here, but I quickly saw that what we have is you end up signing up for this or filling in all these forms, but at the time you submit the information that you're providing, you don't really get a good sense of your chances. So it's as if I'm giving quite a bit of information, and I really have to think about, well, okay, how likely am I going to get something? And I think in the past, Nectar had some of these issues as well. So it's not entirely clear what my chances are, and it would be better if it would be a step forward, I believe, that at this point, the system gave you, based on what some of the information you've given, a score or something that would tell you, okay, here's your chance of getting these publicly funded resources. And then you could come back again at some point and come back with more, or say, no, I'll just do something else. So I think this part was something that the process could have improved on. And then the next thing that you finish up, so if you've done all this, a 2-week turnaround was what I experienced. And this was a big step up, actually, from Nectar, where basically I felt when I requested stuff in the past, it basically ended up in a gap somewhere, and no one came back to me. So I was pleasantly surprised that I got a turnaround within 2 weeks, and I was also given the allocation, so I had asked for a small amount of resources, but I gave a clear reason that I was going to try and use this to do a review, like what you're hearing today. So I was going to review the experience of signing up. So I did get my allocation. It was within 2 weeks, so I thought that was also very good. But the next part tripped me up. So what happens is that you're given then a login on 2 separate systems. One of those systems is the support system, which runs our Jira service desk. And then there's also access to the proper Nimbus cloud, the open stack system that it runs on. So the login and changing of passwords on this, I got tripped up on. So you get the sense that, okay, you sort of have to make sure you know what you're doing. in contrast to, I think, how you do things with AWS and with Azure is even simpler. You don't feel as if there's any separate system at all. Okay, so I gave this 2 out of 4 for the experience here. Then I asked, okay, well, does it improve on the documentation, the can I get things done self-service? I'm a fan of self-service. I'm a fan of if I'm a researcher, can I learn a little bit about what I need to do without having to call upon anyone? Does the GUI provide helpers or little applets or anything to help me do a specific task? But in short, I found the GUI is the same as Nectar, which is to say it's actually just average. It's good enough, but you will need to read documentation to learn the basics. Unless you've met AWS before or Azure or Nectar, you will find yourself having to read a bit of documentation. But of course, it's not too hard to understand most of it. And I think what you'll find, and one of the good things I found was that you can use a few simple commands to get quite a lot done. If you see what I had ended up doing, I hope you feel it's something that anyone can do, any researcher can do. There isn't too much to it that you need to learn where you're already done. Like if you're already using R or Python for your day-to-day work. So what's the verdict about? What is it? Should I use Nectar? Pardon me. Should I use the Nimbus cloud? Is it competitive with AWS and Azure? And I gave this full mark. So I say yes. I'm saying yes, it is. There's no doubt, of course, that AWS and Azure, particularly when it comes to some of the storage options, it's pretty sophisticated, security. But for a research institute, for someone who say you're a PhD and you have to get something done, someone's given you something that they've done and you need to keep it going. I think this is a well-balanced offering, publicly funded. So I would certainly consider this as a useful platform and something to try and get your day-to-day tasks done. And a very important question nowadays, I guess, is a lot of work is now delivered to in a technology called containers. And a lot of people are interested in running web applications. So today's example, which we'll get into fairly shortly, is the R-Shiny web app. So big question then is, can this platform allow me to spin up or to take someone's container, some other research has given me, and can it run a simple R-Shiny web app that they put together so that I can visualize a few things or I can interact with some of their data. And the good news here is that yes, yes it can. It shines, I think, here that the Nimbus cloud provides you, I guess, because it is a cloud service, you sort of bring in some of the abilities of a systems admin to yourself, and you can run Docker, the container platform, and also the Singularity container platform, which is very useful to know if you're going to try and do things more securely, or to try to do things on some of the high performance computing systems that you might run into when your stuff gets, you have to do more stuff. So I found this to be very good. And at this point, I guess it's a good time to quickly stop for a second. And I'm hoping that if there's any questions at this time, we can quickly take them. I'm looking here at the group chat, but I don't see any messages. So I take that to mean there is. Does anybody have anything to say at this point? Anything unclear? Everything's clear. Is everyone awake? All right. So, okay, everyone so far says, okay. I need to remind myself on these online. These are recorded, by the way. So, I think I should hide the names here. And I believe you can speak, yeah, if you need to. I'm not so familiar with the Zoom platform at all. But okay.
So if people want to chat, they're more welcome to chat.
Okay, so you can go here. So at this point, if anybody has anything to say, any questions to ask, and you don't mind yourself being recorded, just feel free to ask.
Or chat is fine.
Or in the group chat, yeah. Okay, looks like
we have one.
Okay. All right, I'll just quickly ask the question. I think this is a question I can read out. So the question is, do beginners need to justify the account with formal research credentials? Now this I have to turn over to you guys at Pawsey. Liv, if you have an answer.
Yep. So that's a good question. So it really depends on the amount of resources you want to apply for. So if it's a small amount, then a brief description of your research and how you want to justify the resources should be fine. But if you're asking for lots and lots of resources, then we would ask for a more detailed description of why you would need all those resources. So if you're a beginner, that's fine. You don't have to have formal academic qualifications. And we got a second question. Can you use your own Docker containers pulled from Docker Hub?
Okay, I'll quickly answer that one. And the answer is, the question is a good one. And the answer is a clear yes. So the example I'm going to run in a short while basically took an rshiny container, right? So I mean, rshiny, if you know or don't know it, is a type of web server. Now, to those of you who don't know what that is, doesn't matter nowadays so much. Like you can get one of these from Docker Hub, and you can adapt it with a few lines of and make it work with your particular web app. So the demonstration will show a little bit of this in a moment. So the question is, answer is yes. Docker Hub, certainly. Okay, so the question, how do you make sure the containers are hardened and secure? So again, this is something, there's a big open question, I guess, in terms of using these things. My view of this is that the Nimbus Cloud, in a sense, is a good platform for short-term, short life cycle tasks. I think what I mean by that is, and I think you might see some of this as we try and do some of the examples, is it's a useful thing for you to set up. So suppose you've got your own secure lab environment or IT environment, and you don't want to take risks there. So you say, well, okay, here's this public platform. I can temporarily instantiate or have some systems quickly set up. I can quickly do what I need to do with some containers that I don't particularly know very much of. Presumably, you're going to rely on another collaborator who said, look, I need you to use this. This is the one that I use as well. So your chain of trust, or their results are reproducible only if you have this particular container. So that's the thing that this kind of platform, I guess, excels at. They're running virtual machines underneath, and eventually, when you're done with what you do or what you need to do, if you're concerned about security, you can just blow those virtual machines away, and you basically don't have anything that you've affected in your secure IT environment at home or in your office or whatever. In terms of hardening, keeping up to date with patches, containers themselves obviously are obviously quite vulnerable to security issues, just like any other system. And in a way, what this lends you, if you automate as much as you can in terms of deployment, which is why I encourage people to look at the example here of how to use some of the commands. If you can automate a lot of these things, you can test as updates occur, and make sure that you're as up to date as possible with whatever web applications you're running. And the final point I think I should make, and I don't want to waste too much more time, but is that the Singularity container platform does have certain advantages that we'll see in a second, that will help if you have concerns about some of the data privacy or maintaining if you're interested in maintaining reproducibility long term. Okay. Is this something that this is something I don't know what UNSW IT wants to do. I mean, this is a question for your particular research group. If you prefer to use the Nimbus cloud, but I mean, UNSW, you have options for systems that are on-premise. You also have some of the systems such as Azure and AWS. For example, Azure you can use UNSW just with your UNSW credentials. So there are certain advantages that you'll find with the commercial platforms. But again, check the local research group or IT policy, before you. So the purpose of this is to show what the Pawsey system can do. It's not saying that you have to do it. It's just one of the options available to you. Okay, any further questions? All right, if there are more questions, we can answer some more at the end, but I'm just going to quickly take you now through the user experience, I suppose. So this is the point at which you finished the sign-up process, you finished getting an allocation, all that's done, and you're ready to do something. Okay, so what happens is that what does it look like? Well, experience is basically this. You go to a website. It's called nimbus.pawsey.org.au. It presents you with a very nice looking screen. However, this screen, I noticed, does require you to remember your password. Otherwise, it's not clear how to reset it. But I figured it out eventually after some confusion. You do have to keep the domain as Pawsey. And then once you sign in, what I did was, the system provides a GUI interface through the web portal, and you can do a lot of the things you need to do navigating through this. I think the documentation provided by Pawsey is typically driven by this, how you use this graphical interface. But I am showing today here not that. I'm just going to show how you would do it if you wanted to use some commands. All right. So the first thing then is you log in and you retrieve something called the clouds.yaml. So it's just a file, a text file, but it's easy enough to retrieve this just by going to the relevant menu. And then once you have this OpenStack clouds.yaml file, you find a place for it on your computer, on your desktop. So in my case, for this test drive, I used my work provided Windows machine. So I created a directory called Nimbus Cloud, and I saved the OpenStack clouds.yaml file in there. Okay, so that was the first step. Then the next step is to, now this is something that hopefully most people already have done before, but it's not too hard. You basically need to install some Python some Python programs. And nowadays, it's very simple to install a lot of this stuff using a packaging system called Anaconda. A lot of people who are using Python these days do use Anaconda. So the chances are pretty good that you already have Anaconda, right? And you already know a little bit about Conda environments. And if that's the case for you, then as a research user, all you need to do is to activate a Conda environment and install two Python what's called clients, or two Python programs. And these commands, these Python command line programs, are all that you'll need to do everything we need today. Okay, so having done that, we're gonna start a VM, a virtual machine, right? A VM. And what we're gonna do is start this virtual machine, and then we're going to set up the containers that we need. In this case, for rshiny, we're also going to pull in the web app. In this case, the COVID-19 visualizer, visualizing rshiny web app, and then we're going to look at, going to see what it looks like in a web browser. So, how do we start a VM? Well, there's a few things before you can do that. You need two things in particular, two important things. You need something called a login key. Generating this login key is a matter of running the command in your Conda environment. And I did this before, so I won't do it again here. But it looks like this. So you run a command that says, generate for me a .pem file. Basically, it is here, and this is my login key, right? So simple command does that, one line command. Second thing you'll need to run a VM is something called a security group, and that's not hard to do from the command line. First, you run one command to create a security group, and then two more commands, which basically just allow two things to happen on this in this security group. And this basically says, allow me to use a shell to log in and allow me to run a web server. Okay, so two more lines. And then we're ready to launch a VM, to launch a virtual machine. So in basically 4 lines, I'm ready. Yeah, so this is actually, to me, this is pretty good. And if you know how to do a bit of scripting, these 4 steps, you could automate straight away, pretty much. Okay. And then the next part comes, okay, it's a little bit of the specific details of the Nimbus cloud. So there are certain images. Images are operating systems. There are certain flavors. Flavors are basically the sizes or the capabilities of the machines. And you would have specified during the application process some of the flavors that you want and the quantities of those flavors. But once you know those things, it's simple enough to just choose Pawsey's own image to do most of the things you need to do. So that's what I did. I just said, right, I'm not going to think too much about images. Yes, there's a list of things I could play around, but let's just go with what Pawsey, the work Pawsey's already done. Let's just choose a flavor, and this refers to 2 cores and 8 GB of RAM. So it's not a large amount of resources, but enough to prove a few things. And everything else is pretty much what I did in the previous step. Right. So another this time slightly longer command, but within a half a minute, I can see information about things happening, and that you can see here things are building. So that's pretty good. And within, I think it was less than a minute. It was pretty fast. I was ready to check what IP address I needed to log in. Right. So this is just then another single line command to show what the IP address is. I've highlighted it here, what came back. Right, and then the next step is just to log in to the virtual machine. And for all of us who have used the SSH, the secure shell, before, this is the sort of command that it looks like. It's you basically specify the key, the login key that we created in step 1. Ubuntu, because Ubuntu is the name of the default user on these images, and IP address is the one that's returned by the system when you start the VM. And upon login, that's what we see. We see basically a Ubuntu. If you've used Ubuntu before, you see a terminal. Yeah, and now we're ready to do something, and you have full control, sudo access to this virtual machine. So that means the full capabilities of Docker and Singularity available to you. So now at this point, I think what we'll do is we'll do something live. So I will do the step that I've done here. So I will start. I'll show what it looks like to start a VM. And I want to show the IP address. So I just covered these steps before. Okay. Here's my IP address, my address to log in. And I shall now log in. And okay, you should be able to see that my live session looks a lot like what I've captured here in the image. Okay, and then now what we're going to do then is we're ready to do some real stuff, right? We've gone through all the setup and IT stuff. So here's a repository for a COVID-19 web app, which we're going to, for this example, run or set up. Hang on a second. Ah, okay. Well, sorry, I had done it earlier. Let me remove the previous one. Okay. So typically, a lot of shiny web apps now are released on GitHub, and so the Pawsey image here already has Git installed, and you can quickly clone the repository that you want, right? And that's what I've just done. Now, this particular web app has two, I guess, slightly idiosyncratic things that it somehow needs to be able to have write access to some of the data files, the CSV files. So I need to do that first up. We need to input data. Show. Yeah, so depending on what web app you're trying to run, there may be some of these things you have to overcome. I found that in this case, this particular author of the web app, for whatever reason, needs some of the CSV files that they've provided to be writable by the web app. I've also made a note here that this particular web app also tries to live update its data from Johns Hopkins University, and in the interest of not changing things, I wanted not to have that happen. So what I did was I commented away the live update. Okay. And so now we're ready to start the R Shiny container. So here we're going to use Docker. Now there are a lot of steps at this point because I had to install additional packages that this particular web app needs, both R packages and things in Ubuntu. So I won't go through that all those steps again, but I can show you here. Just what the steps would look like. So if you repeat all the steps that I've already done in the remaining, there's about 5 other steps. It basically prepares a local image, a local container here called Nimbus local here, right? But the sort of lines that you have to use are going to be very similar. And let's see if let's run this. I have to remove the one that I had previously. Okay. Yeah, so all the stuff that you see here is basically making sure that the R Shiny container can see the web app that I'm trying to run. It's called, in this case, the COVID-19 tracker, right? And at this point, it tells me, yeah, be careful about security, but things are running. Okay, so let's take a look at the web app. So if I go in here and I type in the IP address, and I shut down the hello. There we are. So we have a R Shiny web app running on Docker on the Nimbus cloud. This is a data set that's current until 10th. It's got a little animation here, quite nice that you can get it to just play in the background. And really, that's all there is to it. So once you have an R Shiny Docker container that has the required R packages that you want to use, and that's really where the remaining steps I haven't shown here. I just skipped to the end of that. Once you've done all of that, this container is available for you to restart this thing at any time, and you've very quickly got yourself a web an IP address where other people can, if you've got collaborators that you're trying to demonstrate something, can also come and have a look to see to see the data you're trying to visualize in this case, or whatever you're trying to promote. Okay, so that's any questions at this point. I think it's good. We'll start to wrap up. It's getting a little bit late, but if we have no questions, let me see if there's any questions. Give everyone a few moments. No, have I lost everyone? Yeah. So at some point, I guess you might be interested to try this yourself. So and that's the time where you can, you maybe should go through the application process. And maybe Luke and people at Pawsey will help you with that. But certainly, this is a very capable platform. And okay, so on the final thing to note here is that we don't just have Docker. If you look, so we started this Docker. And, okay, actually, this is a good thing to point out. So as we're running something here, you see a log of all kinds of stuff crawling across the screen here, and this should give you some reminder of some of the risks of running a server, especially if you're trying to keep something running all the time. And there are on this particular on the Nimbus cloud, there is activity here that you can see trying to break, well, yeah, trying to get access to your system. So security is an issue for anything that is running a web server, and if you're, I mean, the mechanisms that are here give you some level of basic security, but you can go further with the Singularity container platform. So I think we're out of time, but if you read on my article a little bit further, if you go and try this yourself, you'll find that the Singularity, so what Singularity gives you, because we're running on a virtual machine with full admin access, we can use the Singularity encryption capability. So Singularity allows you to take these containers in as a encrypted image, single image file. This has some advantages in the sense that once it's encrypted, then it's much harder for someone to get access to the information that you put inside. Not impossible, I think, but it's technically much harder. And the single image file format also has some reproducibility advantages in the sense that one of the criticisms of Docker is that you don't necessarily get the same thing every time. So if you're concerned by such things, then the Singularity format is very powerful, and there is a conversion. If you look at the screen here, basically what I've done is I've said on the Nimbus system, I've said, look, I've already got my local version of a Docker container. Now I want to go one step further. I want to generate the Singularity single image, right? So it's like a single file, which will never be changed. And I'm also going to provide encryption. So I want all this done for me, and indeed this platform does it. So you go through these steps, you end up with a single image file, which is now encrypted, and then the next step, then, if you want to run the web app, the way you have to run the Singularity container as a web app is also slightly more secure in this case. So you have to use something called an SSH tunnel. Without going into too many technicalities, it ends up giving you, allowing you to control who can access this website through an encrypted key. So this is an additional security, additional benefit in security by having converting to Singularity. Not to mention, of course, that if you do use Singularity longer term, it also opens up the possibility of porting some of the workloads if your workload really increases to some of the high performance computers that the Pawsey Center also runs. Okay, so I'm almost out of time. There's one last question. Is the Pawsey Nimbus Cloud part of Nectar or is it separate? I think I should leave that to Luke.
Hi, Simon. Yes, so this is Luke from Pawsey. So Pawsey Nimbus Cloud is separate to Nectar. So we run that independently at Pawsey.
All right, thanks, Luke. Thanks very much for that. So I hope everyone's learned something today. Yeah, please feel free to either contact myself or the guys at Pawsey to learn more. And I'm sure you will find this a useful platform for your research work. Thank you very much, and hope to see you around soon.
Thanks, Simon. Thanks for everything.
Thank you, Luke. Back to you now. I'll stop my sharing.
No worries.